Hi guys, and welcome to another video. Today's video lesson, we are continuing on the series of proving trigonometric identities. As you can see here in the work schedule, we are at this point, which is proving trigonometric identities, and all previous sections have been covered in previous videos. So let's get straight into it. First question that I want to look at today under proving trigonometric identities is from the November 2015 paper 2. And let's go and look at that particular question. Now, this question here, 5.2, as you can see, it says determine the value of the following expression. Now, this is not an identity per se, where you're proving the left-hand side equals to the right-hand side. However, whatever you use in proving trigonometric identities, you are going to use in solving this particular example right here. So you have to know, as discussed in the previous video, that tan of x is equal to sine x over cos x, and sine squared x plus cos squared x is equal to 1. So let's write this down and let's simplify it. So therefore, for 5.2, our solution is now going to be as follows. So 5.2, so we got 2 sine x times cos x, as you can see here, 2 sine x times cos x. So let's do this, right? Let's just open out the brackets here. So 2 sine x cos x times 1 is 2 sine x cos x, and 2 sine x cos x times tan squared x is going to give us this, plus 2 sine x cos x times tan squared x times tan squared x. And we are left with bottom here, tan of x. Now, whenever we got tan of x, it's advisable for us to write it as sine of x over cos of x. So let's write that down, sine of x over cos of x, which will now equals 2. As you can see here, you got tan squared x. The tan squared x, once again, we want to write that as sine squared x over cos squared x too. So we're going to be left with 2 sine x times cos x plus 2 sine x times cos x times sine squared x all over cos squared x, and that's going to be all over sine x over cos x. So let us simplify further. As you can see here now, you can cancel this cos x with 1 cos x from the bottom there. Okay, so now remember now that this is 2 sine x cos x, you can write it over 1. So the concept of LCD exists here now. Remember that my LCD now on the top here is going to be 1 times cos x, which is going to give me cos x. So therefore, I'm going to write that down. My LCD for my numerator is going to be cos x. So therefore, I'm going to be left with 2 sine x times cos squared x. Remember, 2 sine x cos x times cos x is 2 sine x cos squared x, plus here I'm going to be left with 2 sine x, sine x times sine squared x. So let's write it as sine cubed x. Right, so we got sine cubed x, and you see this over here in the bottom here, you got sine x over cos x, right? What we can do is we can change this division to multiplication and write it as invert the bottom fraction, so it becomes what? Cos x over sine x. So there you go. So as you can see now, what do you have? You got cos x cancels with cos x there, right? So you got cos x and cos x now cancelling each other out there. And what do we have here? Let's see. So we got 2 sine x cos squared x plus 2 sine cubed x, which is now going to leave us with the following: 2 sine x. So we got 2 sine x. We can take that out as a common factor. And what are we going to be left with here? We're going to be left with cos squared x plus sine squared x. So we got 2. Don't forget now that the sine is times 1 over sine x is still left there, right? So therefore, if you look very carefully now, cos squared x plus sine squared x is 1, and then the sine x from there and the sine x there is going to cancel, so you're going to be left with a value of 2. So therefore, the value of this particular expression now simplifies to 2. Okay, so that's basically our solution. Let's go look at another question. So in this particular paper now, this is the November 2017 paper 2. And let's look at a question here. So this is 5.4. It says prove the identity. Prove the identity. So here you got the left hand side. There's the right hand side there. So we're going to write down here left hand side equals to sine of theta minus tan of theta times cos squared theta. So it's going to be minus sine of tan of theta. Let's write it as what? Sine theta over cos of theta times cos squared theta. Right? So I just now remember, whenever you got tan of theta, you want to write sine theta over cos theta, right? Then over here I got cos theta plus, rather minus 1, cos theta minus 1 plus sine squared theta. Now I can change the sine squared theta to what? Remember, sine squared theta is equal to 1 minus cos squared theta. Because you got a plus on the outside here, you don't need to use brackets, right? So you're going to say cos theta minus 1 plus 1 minus cos squared theta. So what happens here? See your minus 1 there and the plus 1 both cancels, right? And over here, what you're going to be left with, see that 1 cos theta, see that's over 1, right? So you can put it here, cos theta and 1 cos theta cancels from there. So if you look very carefully, you'll be able to see that you got sine theta as a common factor on the top, which you can now remove, right? So you're going to be left with sine of theta into 1 minus cos of theta. And then over here, you're going to be left with, see, cos theta you can remove as a common factor there. Cos theta into 1 minus cos of theta. You're removing that cos theta as a common factor. So 1 minus cos theta and 1 minus cos theta both cancels. And therefore now you're going to be left with tan of theta, which is equal to my right hand side. So that's that identity now proved. And you can see left hand side is equal to the right hand side. Learners, if you haven't subscribed already, subscribe to JL Maths, my YouTube channel, like my Facebook page, Justin Lazarus Mathematics, and also you can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.